Hi everyone, I'm just carrying on from the last video. I'm of course using a free um, recording software or extension, so therefore it's limited, of course. So regression line. So this line is the line of best fit. So what this red line is telling me is that all the data is kind of centered around here, okay? And there's a very powerful mathematical formula that goes into constructing this. Now, an R value, this R value is 0.43. We vaguely spoke about this, and I told you last time if you get an R value of like 0.8 or 0.85 or zero point 0.9 and 1 is the maximum you can get. Notice also this is positive. That positive means there's a positive correlation, by the way. Positive correlation means as weight increases, so does height. If this number was negative, the red line would be going kind of down that way. Remember lines from last year, having a negative gradient means that line is decreasing. So here we are, that R value, once again, this is used mainly in year 13, but you know what, we can just learn it a little bit now. So that there is what we say is a positive number, so that the gradient of the red line is positive, meaning positive correlation. Now it's weak. It's not that strong because that number is not really like 0.6 kind of means, yeah, it's a strong relationship. A very, very strong one would be like 0.8 and above. So this is in the region of like, there is a relationship, but I wouldn't put my house on it, etc. If this is 0.3 or less, it'll be a flatter line and a flat, so to speak. So this is when you draw scatter graphs, when you're comparing two numerical variables. I think it was someone in class, who was Sonia, who told us the other day that, or today actually, and I said, could you actually have a continuous, oh, sorry, these are both continuous variables, but could you actually have a discrete variable as one of the variables in a scatter graph? And I said, yes, you could actually. And I'll show you quickly in one of these data sets, hopefully, how that looks like. But before that, before I run away, yeah, this is when you draw scatter graphs. The purpose of scatter graphs is to find a correlation. Correlation meaning a statistical relationship. In two variables like this, one possibility is as one increases, the other increases. Or if one increases, the other decreases. And vice versa. Vice versa meaning if one increases, the other decreases. Or if one increases, the other decreases. Did I say that? Maybe the other way around. Exactly. So there's four possibilities. And if I quickly go to some Google images, scatter graph relation. That's correctly. I did. So images, so you have lots of scenarios like this. So that there's what we call a positive correlation, negative. There's hardly anything. There's lots of images out here, that's a negative, negative. So that means both the variables are decreasing as the relationship between them is not positive, rather. See, as this variable is increasing and that increasing, the relationship is decreasing. So you can have a graph like that. You can have a graph going up like that as well. You can also have a flat line, which means it's pretty bad. There's no relationship at all. And those are some advanced ones. You can wait till you get into your 13 stats to watch these ones. Right, let's go back to my grow. Let's see if I can find a video very quickly before I run out of recording time. Ooh, gotta be really quick about this. Let's see. Jobs. I don't know jobs. No. Sometimes there are built-in data sets which are pretty neat, actually. Oh, okay. So here's a data about cars. It doesn't quite tell me what it's about. I wish it did. Does it tell me somewhere? Anyway, so let's see. Car name. Where does it come from? An overseas country. Um, I'm sure it comes from Japan anyway. The price of the car, I'm guessing, is $22,700. I don't know if it's US or NZ. Compact car. City. Oh, okay. So this is how much mileage you can get, I think, I think this is per gallon. I don't think this will be per liter. Otherwise, the car is way too economical. By the way, gallon is, you can Google how many liters in a gallon, etc. So let me quickly see if there's a correlation between engine size, which happens to be continuous variable because it comes in decimals as well, and and the city driving. I hope this will do us a graph, which is what I need. So I'm trying to predict the 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 driving output while driving in a city with engine size. So I'll put engine size here, and I'll put city there. Okay, now if I have a ruler, sometimes you can get a ruler here, and you can kind of drag this ruler, but I don't. Can you see all the data? They kind of fall in vertical lines and they have gaps. A bit of a gap, vertical, bit of a gap. So they're not kind of scattered like the one we had before. You can rewind the video and watch it. Scattered, all over the show. So this is what happens when you have a city which is a data which comes in sort of whole number forms. It's still qualitative data, but it is discrete actually. So I thought I'd quickly mention that that was mentioned in class today. So I hope that made sense to you. I'll yeah, do your comments on the video and how you feel about it, but hopefully that helps your learning, folks. All right, gotta take my dog for a walk.